Welcome back to another explainer. Today, we're tackling a massive, absolutely crucial topic in the world of sustainability. How do we actually, scientifically, measure the environmental benefits and drawbacks of the products and services we use every day? It's a space where assumptions can easily masquerade as facts, and that's exactly why we need rigorous frameworks to guide us.
Okay, let's dive into this. Can two life cycle assessments, or LCAs as we call them, of the exact same product actually differ? The short answer, yes, absolutely. Think about it. If we set out to measure the carbon footprint of an electric car, but you only look at the tailpipe emissions and I look at the mining of the lithium for the battery, well, we're going to end up with wildly different results. Without a unified, standardized system, measuring environmental impact just becomes absolute chaos.
So here is our roadmap for today's explainer. 1. Why do we need standards? 2. ISO 14040, the framework. 3. ISO 14044, the methodology. 4. The 4 core phases of an LCA. And finally, number 5, how we ensure quality and public trust.
Let's kick things off with Section 1. Why do we actually need standards?
Imagine a world where every single company uses a completely different ruler to measure their own sustainability. We'd literally be living in a wild west of data, where every corporation claims to be the absolute greenest, and we, as consumers, would have zero way to verify it. To solve that mess, global standards give us 3 vital pillars. First up is consistency. This ensures that different LCA studies follow the exact same structural logic. Next is transparency. You've got to make your assumptions in your data sources clearly visible to anyone reading your study. And third is comparability. Now, this is the holy grail. It's what allows us to actually compare the environmental impact of, say, a paper cup versus a plastic cup fairly. Without these 3 pillars firmly in place, life cycle assessment results just wouldn't be reliable. We simply couldn't trust them.
Moving right along to Section 2, ISO 1440, the framework.
I want you to think of ISO 1440 as the architectural blueprint for the entire process. It provides the conceptual guidance. It sets the overarching foundation and defines the broad principles of life cycle assessment. But, and this is crucial, it does not go into the deep technical weeds. It's really designed to explain the what of life cycle assessments. It tells you what an LCA is and broadly how an organization should approach it, but it intentionally stops short of handing over the complex mathematical formulas.
Which brings us perfectly to Section 3, ISO 14044, the methodology.
So if 14040 is our architectural blueprint, 14044 is the detailed, step-by-step construction manual that actually brings that blueprint to life in the real world. This standard is all about the how. It takes that general framework and operationalizes it by specifying the highly detailed requirements you need to actually execute the study. We're talking strict technical guidance, super specific rules for data collection, how calculations have to be performed, and exactly how the final report must be structured. Basically, it takes the theory and turns it into rigorous boots-on-the-ground scientific practice.
And this brilliantly illustrates the dynamic between the two. ISO 1440 is the what, the foundational framework. ISO 1444 is the how, the precise methodology. You really can't just use one or the other. In actual real-world sustainability practice, both of these standards have to be used together to produce a valid, trustworthy life cycle assessment.
All right, let's look at how this plays out in Section 4, the 4 phases of LCA.
Now, what's really interesting here is how we map the actual journey of a product. We start right at the beginning with the goal and scope. Let's say deciding to look at a specific type of car. Then we move into the life cycle inventory, or LCI, where we literally catalog every single resource used and emission released across its entire life. We're talking from raw resource extraction all the way to final disposal. From there, that massive inventory of data flows into the impact assessment. That's where we translate those raw emissions into actual tangible environmental impacts like climate change, ozone depletion, or land use. And finally, it all leads to interpretation.
So just to formalize that workflow, we have 4 distinct steps. 1. Goal and scope definition, which clearly sets our purpose and our boundaries. 2. The lifecycle inventory, where we're gathering all that vital input and output data. 3. The lifecycle impact assessment, which evaluates the real environmental significance of the data. And 4. Interpretation, where we analyze the results and draw our final conclusions. But you know, if you look closely at standard practices, you'll quickly realize this is definitely not just a simple straight line.
So the crucial point is that an LCA is highly iterative. It is absolutely packed with feedback loops.
As you're gathering data in Step 2, you might suddenly realize your initial scope from Step 1 was completely unrealistic. That forces you to go back and adjust. Or maybe you hit the interpretation phase and realize your data quality on a specific chemical is just too poor to draw a solid conclusion, sending you right back into the inventory phase to dig deeper. It's a process of continuous refinement. Honestly, it completely destroys the illusion that environmental assessment is just a simple, one-directional calculation. To ground all of this iteration, ISO 14044 requires some very strict definitions right out of the gate, starting with the functional unit. This defines exactly what is being assessed. Think about it. You aren't just measuring the impact of paint, you are specifically measuring the amount of paint required to cover 10 square meters of wall for 20 years. Deciding what this functional unit is, that fundamentally anchors the math for the rest of the entire study. Equally important are the system boundaries. This determines precisely what processes are included or excluded from the assessment. For instance, are we measuring the environmental impact of a pair of jeans just from the cotton farm to the factory door? Or are we measuring it from the farm, through the factory, into the consumer's washing machine, and finally out to the landfill? Choosing exactly where to draw these boundaries, alongside the rules for how you allocate emissions when a factory produces multiple different products, heavily dictates the final outcomes of the LCA.
Let's move to our final topic in Section 5, ensuring quality and trust.
At the end of the day, all of this incredible modeling is pretty much useless if the public and policymakers can't trust the data. To solve this, ISO standardizes strict data quality requirements to ensure results are completely credible and not just, educated guesswork. Your data must have completeness, meaning all relevant information is actually included with nothing conveniently left out. It needs consistency, so the exact same assumptions are applied uniformly across the whole system. It requires accuracy, meaning the data has to reflect actual real-world processes, not just theoretical models. And finally, transparent reporting. Every single assumption, choice, and method must be painstakingly documented. And if you're going to use an LCA to make a comparative assertion publicly, like, for example, if a company wants to run a massive ad campaign claiming their product is 50% better for the environment than their competitors, well, the standards actually mandate a critical review. A panel of independent experts has to step in and review the LCA. This transparent reporting, combined with the critical review process, really acts as the ultimate necessary safeguard against greenwashing and bad data. Which leaves us with this final provocative thought to chew on. How do the choices and assumptions made by an analyst ultimately dictate the reality of the LCA results? As we've explored today through the ISO frameworks, data isn't just data. It's heavily shaped by where we draw the boundaries, how we define that functional unit, and the absolute rigor of our data quality. Mastering the methodology behind the numbers is truly the only way to interpret the results, see through the noise, and understand the real environmental impact of the world around us. Thanks so much for joining me on this explainer, and keep questioning the data.